As this one is next lecture of electrostatic, I need to find out electric field due to dipole at any point P. So this is one dipole and distance between these two charges 2a. I need to find out electric field at point P at distance r from midpoint of this dipole. And this angle is theta. This angle is not 90 degree. If it becomes 90 degrees, that will become equatorial line. And if this angle is 0 degree, means if I rotate this line, if this angle becomes 0 degree, that will become axial line. So I am not asking about axial line or equatorial line. I need to find out electric field at any given point P for angle theta. So for this one, guys, what we have to do? We already know electric field due to dipole at axial line. If this one is one dipole at axial line, I need to find out electric field. In this case, what do we get? Electric field at this point at distance r. We already have done this derivation. At distance r, electric field due to this dipole E is equal to 2 kp divided by r cube. This is for axial line. And for equatorial line, this one is minus q, this one plus q. And at this point, if you have to find out electric field due to this dipole, this one also we have done an answer for this, that is kp divided by r cube. If you see the previous lecture, I have done electric field due to dipole at axial line, answer was 2 kp divided by r cube, and electric field due to dipole at equatorial line kp divided by r cube. Now what I have to find out? Electric field due to this dipole at any point P. See, if this angle become theta, this angle become 90, so this is equatorial line. And if this angle becomes 0, if I rotate this line, this angle becomes 0, it means this is axial line. So what we can do over here, I divide this dipole into two components. See, dipole moment will be this one. P is equal to Q into 2A. Now, if I divide this dipole moment into two components, a vector quantity, and direction of this dipole moment from negative charge to positive charge. If I divide this one into two components, one is parallel to this line and another one is perpendicular to this line. So perpendicular to this line R, I make another line that is perpendicular to that R. So this is what plus Q and this one minus Q. Just I rotated this line. This angle is theta, so this angle will be 90, this total will be 90, this total will be 90, so this angle will be 90 minus theta. Means if dipole moment minus to plus, dipole moment always from minus to plus. So dipole moment P from minus to plus means this direction, if this one is P, this direction dipole moment is P, so along this line that will be P cos 90 minus theta. It means that will be P sin theta. Now, dipole moment P along this line, that will be P cos theta. See, just like vector, we divide into two components. One is cos component, another one will be sin component. So this component of this P along this line, that will be P sin theta, and component of this P along this line, means along this, we can divide like this, along this one. So this is plus Q and this one minus Q. So this one will be like. So along this line it's a P cos theta, and along this line it's a P sin theta. Once again I repeat this one. Dipole moment is P along this line. Now if I divide this P into two components, along this line it will be P sin theta, and component of this P itself along this line, that will be P cos theta. So if you look at this diagram, this line, this is one dipole and this line is perpendicular to that. Again, this one is another dipole and this R line parallel to that. Once again I repeat, this is one dipole and this line R parallel to that dipole. It means it's just like a axial line. See, this is one dipole. What's the direction of this dipole? Minus q to plus q. And I need to find out electric field at this point. It's a parallel to that. It means here, this is one dipole. I need to find electric field at the same line. It means both are parallel. So for this one, what I can write, E1 is equal to 2kp. In place of p, I write, see, this one is formula 2kp divided by r cube. In place of this p, I'll write p cos theta divided by r cube. Similarly, if you see this line, this dipole and this line r, they are perpendicular, same like this. This dipole and this are perpendicular. And what's the formula for this one? Kp divided by r cube. In this case, what I'll write, E2 is equal to kp. In place of p, what I write? P sin theta. So p sin theta divided by r cube. Now, if we see this E1 and E2 both are perpendicular. One is along this line and another one is perpendicular to that. It means one is along this is E1 and this one is E2. So both are perpendicular. So if I want to find out net electric field due to this dipole, in that case, what I'll do, I'll add these two as a vector quantity. So if I add these two as a vector quantity, what I'll get? E is equal to under root E1 square plus E2 square. So if I add this one and I put that value, I'll get E is equal to under root 2kp r cube cos theta square plus kp divided by r cube sin theta square. And if I solve this one properly, I'll get E is equal to kp divided by r cube, and here I'll get under root 4 cos square theta plus sin square theta. We can simplify this one a bit. I can write kp divided by r cube. So this one will be 3 cos square theta plus 1, because cos square theta 1, cos square theta plus sin square theta, that will become 1. So this will be 1. So for electric field at that point. Now, if I want to find out for axial point, this is for any point, for any angle theta. So if I rotate this line, let's say I want to find out at this point. So if I rotate this one, so this angle becomes 0, this theta becomes 0. It means I am talking about axial line. So for axial line, if I write theta 0, you know cos 0 how much? Cos 0 become 1. So what I'll get? E1, E axial line. For axial line means if I rotate this line to this point, so what's a theta? Theta will become 0, same line, so if theta becomes 0, in that case if I put theta 0, it means I am talking about axial line. I put this point over here, just I rotate this line. Hypothetically, I rotate this line over here. So theta becomes 0, so if I put theta 0 over here, so cos 0 is 1, so 3 plus 1, that will become 4, and under root 4, 2 become out, 2 will be outside. So this become 2 kp divided by r cube. We already know for axial line, this is the formula. So this is the general formula for any angle theta. If I ask about axial line, what you have to do in place of theta, you need to write 0 degree. Now, for equatorial line, if I want to find out here, so this point P I rotate over here. So if I rotate, this angle become 90. If I rotate like perpendicular to this line, perpendicular to minus q to q, so that become 90. So if I put theta 90, cos 90 how much? 0. Cos 90 0, and theta is 0, so cos 90 becomes 0. So this term will become 0. So what I'll get? Under root 1, that is 1 only. So I'll get kp divided by r cube. So this is for equatorial line. Means if I remember this formula, if anybody remember this formula for any arbitrary point, for any angle theta, electric field to dipole at any angle theta, this is the formula kp divided by r cube under root 3 cos square theta plus 1. For axial line, what you have to do? In place of theta, you have to put 0 degree. You'll get axial line. For equatorial line, what you have to do? In place of theta, you put 90 degree. So we'll get for equatorial line. Thank you.